What I want to do in this video is find the derivative of dy. What I want to do is, if y is equal to the sine inverse of x, which is also written as arcsin of x, what I want to do is I want to find dy by dx. What is that going to be? This is not as straightforward, but it is. Let's just get to it. Okay, so here we have the equation y is equal to sine inverse of x. Now what if we take the sine of both sides, right? Taking sine of both sides, we get sine of y is equal to sine of the sine inverse of x, right? So this becomes sine of y is equal to sine of sine inverse. I guess that is sine of sine inverse of x is nothing but x, because if you take the square root of the square of something, you'll get that same number again, right? So that is kind of the trick here. Okay, so sine y is equal to x, and now what I'm going to do is I'm going to take the derivative of both sides. So let me do it here. D by dx, and derivative with respect to x, okay, of sine y is equal to derivative with respect to x of x. Okay, so what where do we get using this? Now d by dx of sine y, this involves the chain rule, so this becomes the cosine of y times the dy by dx, and that is equal to d by dx of x is just 1, right? So we get that dy dx is equal to 1 over cosine y, which is the secant of y. Dy by dx in terms of y, but we need it in terms of x. How do we do this now? Well, we have this equation, right? So how can we generate secant y from sine of y? Well, we can write secant of y as 1 over cosine of y, and cosine of y as 1 over the square root of 1 minus sine squared of y, right? That is just the basic trigonometric identity. Now this will become 1 over the square root of 1 minus sine of y is x, so this becomes x squared. So there it is. We have found out that the derivative with respect to x of sine inverse of x is 1 over the square root of 1 minus x squared. Okay, so there you go. This trick or this method is applicable to even cosine inverse and tangent inverse of x. You can try that out try it yourself. This helps in somewhat some integrals, which I'll do in my future videos. So yeah, you can also do this for cosine inverse and tan inverse. Okay, so I hope you like it, and I'll see you in the next video.